Welcome back to Standard 6th, Lesson number 5, Substances in their surrounding, their states and properties. In the previous lecture, we have done different states of matter, solid, liquid, gas and plasma we did. There is the fifth state of matter, Bose-Einstein condensates. We learnt about properties of solid. Solids retain a fixed volume and shape. They are rigid. Particles are locked into place. They are not easily compressible. Little free space between particles are there. Does not flow easily. Properties of liquids. Liquids assumes the shape of the part of the container which it occupies. Particles can move or slide past one another. Liquids are not easily compressible. Little free space between particles are available. It flows easily. Particles can move or slide past one another. Properties of gas. Gas assumes the shape and volume of its container. Particles can move past one another. They are compressible. Lots of free space between particles. Gases can flow easily. Particles can move past one another. Here is the table which will define solid, liquid, have definite volume, definite shape, temperature increases or decreases, whether they are compressible or not. Have a look on it. So it is very clear that solids have shape and fixed volume, whereas liquids occupies the shape of the container. It has free space, free surface, fixed volume. Gases, it occupies the shape of the container and volume of the container. Today we will look into changes of states. We will be seeing melting, freezing, sublimation, deposition, condensation, boiling. The different physical and chemical changes which takes place in the states of matter. First, physical changes. The states of matter that are physical changes, solid, liquid, gas. The states of matter change by adding or taking away energy. This includes melting, boiling, evaporating and freezing. Physical changes alter a material. Without changes, it gets chemical composition. Physical changes can be classified as reversible or irreversible. Reversible changes means it can melt, it can freeze, it can boil, it can condense. Whereas irreversible changes, for example, once it is broken, you cannot join it back as it is. Splitting, grinding, cutting and crushing are all irreversible changes. Physical change, a change in the state or form of substance without changing the identity of the substance. A physical change alters the form of a substance but does not change it to another substance. It changes shape or size, it dissolves, it changes phase. For example, it freezes, it boils, evaporates, condenses. Example, making orange juice. Physical change occurs when matter changes its property but not chemical nature. Physical property changes could include a change in texture, shape, size, color, order, volume, mass, weight and density. A boiled egg, crushing an aspirin are the examples. Cutting paper, ice melting. The various uses of changes in physical state. Candles are made by melting paraffin wax. Solid carbon dioxide, that is dry ice, is used to make ice cream and to keep it frozen. Liquid nitrogen is used in animal husbandry. Sand is melted to make glass. Metals like gold and silver are melted to make ornaments. Iron is melted to make tools. Chemical properties and changes. Chemical changes are changes matter undergo when it becomes new or different matter. It burns. Temperature changes without heating or cooling. It bubbles. It changes color. It forms a precipitate. When a substance undergoes a chemical change, it changes into a different substance with different properties. To identify a chemical change, look for signs such as color change, bubbling, fizzing, light production, smoke, and presence of heat. Example, baking a cake. Indicators of chemical change. If you make two or more of the following observations, a chemical change has probably occurred. Heat is produced or absorbed. The starting material is used up. A new color appears. A starting color disappears. A material with new property forms. Gas bubbles form in a liquid. Grains of solid precipitate form in a liquid. The signs of the chemical change: precipitation, color change, temperature change, gas production. A chemical change occurs when fireworks are used. Fireworks are made of metals such as magnesium and copper. These change chemically as they light up the sky. Examples: sugar dissolving in tea, logs burning, breaking water up by separating it into hydrogen and oxygen, toast burning, rocket fuel burning, metal rusting. When the chrome on a bicycle rusts, it can never go back to being chrome. What is chrome? The paint which is used. When an egg is boiled, it can never go back to being a raw egg. Let's understand what is temperature. Temperature is the degree of sensible heat or cold, expressed in terms of specific scale. The clinical thermometer, the digital thermometer, which is used now for the pandemic, which is our country facing. The different types of thermometer available. Several scales and units exist for measuring temperature, the most common being Celsius, Fahrenheit, and especially in science, Kelvin. Boiling water has 100 degrees Celsius, freezing water 0 degree. Air in winter night is more than 15 degrees Celsius. Air summer afternoon is less than 35 degrees Celsius. Inside a fridge, more than 5 degrees Celsius. Inside the freezer, more than minus 18 degrees Celsius. Body temperature approximately 37 degrees Celsius. Boiling. What is meant by boiling? The transition of liquid into vapor. Boiling begins when the liquid is heated to the point at which the pressure of the saturated vapor above its surface becomes equal to the external pressure. You can see the picture. Boiling is the change of state that happens when a liquid turns into a gas. Like melting, boiling usually requires energy. Water is continuously evaporating. We know that water spilled on the floor dries up slowly on its own. This evaporation occurs from the surface of the water. What happens when water boils? As the water gets heated, its temperature increases and it evaporates at a faster and faster rate. When water kept on a stove attains a particular temperature or level of heat, then evaporation takes place in all parts of the body of water. Then we see water bubbles rising at faster and faster rates to the surface and steam mixing in the air. This is called boiling of water or ebullition. At sea level, pure water boils at 100 degrees Celsius. This is the boiling point of water. When water vapor cools, it is converted into water again. This process is called condensation. Condensation of steam also takes place at 100 degrees Celsius. It means the boiling point and condensation point of water are one and the same. Freezing. The water kept in fridge or on ice becomes cooler and cooler. That is, its temperature falls. At a certain temperature, water does not get any cooler, but starts freezing and forms ice. The temperature at which this happens is called freezing point of water. The temperature of a substance can fall below 0 degrees Celsius. Example, the temperature of air in the freezer of a refrigerator is around minus 18 degrees Celsius. It is read as minus 18 degrees Celsius. When ice gets heat, it starts melting or changing into the liquid state again. Ice melts at 0 degrees Celsius. It means that the freezing point and melting point of water are one and the same. Each substance has a specific boiling point, which is also its condensation point. Each substance has a specific melting point, which is the same as its freezing point. Look at the picture. The boiling point of water is 100 degrees Celsius, whereas the freezing point of water is 0 degrees Celsius. Melting and freezing. Melting is the change of state that happens when a solid turns into liquid. In most cases, energy must be added for substance to melt. For example, ice on stove absorbs heat energy. Freezing is the change of state that happens when a liquid becomes a solid. In most cases, energy must be removed for a substance to freeze. For example, put water on your fridge. The liquid will lose energy and slow down. The particles will get closer to one another, becoming solid. Boiling point of solution, freezing point of solution. Normal boiling point, normal freezing point. Have a look on it. Sublimation. Iodine crystals do not melt on heating but change directly to gaseous state. When the fumes of iodine hit the walls of the funnel, they cool to form solid crystals of iodine and stick to the funnel walls. Thus, on heating, iodine does not melt and change to a liquid, but directly changes to the gaseous state. The change of a solid substance directly into a gas or vapor without first changing into a liquid is called sublimation. Sublimation is the change of state in which a solid changes directly into a gas without going through liquid state first. Sublimation happens to some substance like dry ice, solid carbon dioxide, or snow. Evaporation involves a change of state from liquid to gas, but unlike boiling, evaporation occurs only at the surface of a liquid. Condensation, when a gas turns into liquid, and in this case water vapor in the air condenses into liquid water. Evaporation, the change of liquid state to gas state after heating. Water changes to water vapor by heating. Condensation, the change of gas state to liquid state by cooling. Here, look at the picture, liquid to gas and gas to liquid. Liquid to gas is evaporation and gas to liquid is condensation. One is heating, another one is cooling process. So, you can see the transition of state of matter. Look at the picture, gas to liquid, condensation, liquid to gas is evaporation. The process of conversion of water into vapor by heating is called evaporation. Condensation is the change of physical state of matter from the gas phase into the liquid phase and is the reverse of vaporization. It can also be defined as the change in the state of water vapor to liquid water when in contact with a liquid or solid surface, or cloud condensation, nuclei within the atmosphere. What is necessary for a phase transition change to occur? All what we saw requires energy. Energy is the ability to do work. Energy is required to change the phase of a substance, such as the energy to break the bonds between molecules in a block of ice so it may melt. During a phase change, energy may be added or subtracted from a system, but the temperature will not change. So energy plays a major role in the transition of states of matter. Thank you so much. Stay safe.